the horizontal video. You don't
I know, but I don't need to do this. Okay. Okay, ladies and gentlemen, we have Dr. Dixon here. Dr. Dixon is our guest speaker for the day. Dr. Dixon is amazing. He is going to talk to you about
the reason why some elements let go of their valence electrons easier than others, which makes them more reactive. So if you look at the Bohr model for lithium, then we also have sodium and potassium. Okay, each one has different shells. Okay, so how many shells does lithium have? It has 2. So we draw 2 shells. Lithium. Potassium has 3 shells here, or the sodium. And potassium has 4. 2, 3, 4. And if you look at the amount of protons with each, lithium has 3 protons at its center. Sodium has 11 at the center, at the nucleus. And potassium has 19. Okay? So 19 protons. And so the number of protons matches the number of electrons. So in the Bohr model shells, we're going to have 2 electrons on the first shell and 1 on the outer shell. Sodium, we're going to have 2 on the first shell, 8, and then 1. And the potassium, we have 2, 8, 8, 1. Okay, so the distance between these protons in the nucleus, okay, there's also neutrons there, but they don't have a charge. The distance is increasing from the nucleus to that valence electron. And if you guys remember your equation, the electrostatic force is equal to K, which is the electrostatic constant, times Q1 times Q2 over R squared. So K is a constant, never changes. Q is a charge of the collective charge of the number of protons, so I'm just going to put a little plus up there. Q2 could be the charge of the electrons, so it's a minus. They're the same charge, they don't really matter. So this number's not going to change, these 2 numbers aren't going to change very much. However, down here, this number is going to change the most. Okay? When you increase the distance between the nucleus to that valence electron, this force decreases with very rapidly. Okay? And so when this force decreases, you have lithium holding this electron very tightly, whereas sodium's slightly less tightly, potassium slightly even less tightly, holding on. That force, that electrostatic force, decreases as you increase the distance. So if you look at your periodic table, as you go down, the distance from the nucleus to that center, that valence electron, increases, and therefore the electron gives the valence electron is given away more easily. Now if you look over here, these ones here take electrons, they don't give the electrons. So the atom gets smaller as you go up the periodic table. So it's the same force here, okay? So these ones, as you go up, the distance is going to get smaller, so they're going to take those electrons and hold them even tighter. So as you move up the periodic table, you hold the electrons tighter. As you move down the periodic table, you give away the electrons more easily. And so the most reactive, I guess one of the more reactive, what's the word I'm looking for? Just reactions, I guess you could make, would be cesium combined with fluorine gas. Okay, because fluorine holds electrons very tightly, cesium gives them away very easily, and that would be a huge explosion, right? Wouldn't it be? Yeah. That's it.
do your thing.
Oh, you want me to do the sodium thing?
Yeah.
Okay. Now let's go over and take a look at sodium and how it reacts with water. So then we go over here.
Dr. Dixon on leave from NASA.
All right. Some water in here.
Why water, Dr. Dixon?
Because water is 2 hydrogens and an oxygen, and hydrogen is in the same family as lithium and sodium and potassium. And let me get a wave over here.
So what's in the jar here, Dr. Dixon?
We just have sodium metal. They have to pack it in oil so it doesn't oxidize. It already has an oxidation layer over it. That's why it's white.
What does oxidizing mean, Dr. Dixon?
It means combining with the oxygen in the air.
What kind of oil?
This is mineral oil. Get a paper towel. So when you take out the sodium,
Is it soft?
it's very soft. As you move down the periodic table, the metals get softer. So
This is metal?
this is a metal.
How can you cut metal with a knife?
Because that's the properties of this type of metal. You're going to get some of that oil off of there so it reacts a little better with the water. You get a little flame going here for part of the demonstration later. Okay. So if you don't even need an X-Acto knife. You can cut it with a butter knife if you wanted to. So soft.
Why don't you handle it with your hands, Dr. Dixon?
Because you